In this video, we are going to discuss about the graphs of inverse trigonometric function. See, to understand about the graphs of inverse trigonometric function, first you need to understand how we get the range and domain for that inverse trigonometric function. Okay, this using the graph, we can explain it in a very easy way. See, first and foremost, you need to understand the basic definition of an inverse function. How did we define it? It has to be both one-to-one and onto, correct? It has to be a bijective function. So, if you take an example of sine curve, okay, so sine x, if you take y is equal to sine x, right? So, you know that x belongs to R, whereas y belongs to minus 1 to 1. This much we know, right? And we also did this in the previous video. Whereas, if you take y is equal to sine inverse x, then our domain is very easy to calculate. That is, x belongs to minus 1 to 1, whereas y does not belong to R, correct? Let's understand that using a very simple graph. Look at this particular graph. See, you have y is equal to sine x. This is basically the graph of sine x. But a very important parameter is, see, here if you see this point, this is basically the maximum value. So we can say that this is pi by 2, comma 1, correct? Same thing if you look at this point is going to be minus pi by 2, comma minus 1. Make sense? Okay, well and good. Now, any value of sine function, any value of sine, take any real number. Every value is between this value of minus pi by 2 to this value of plus pi by 2, correct? Make sense? Because look at this, it's repeating everywhere. So first condition is what? If we need to have an inverse function, the function has to be 1 to 1, or you can say it has to be injective. Any value of, if you take any real number, will it be 1 to 1? No, it cannot be 1 to 1. Think about it. Suppose you take pi by 2, so it's going to be the same value. If you're going to take this value, again that value is also equal to 1. So how can it be 1 to 1? Not possible, right? So to have that 1 to 1 condition, plus I should also get all the values of sine function, because sine function varies from minus 1 to 1, right? So what do we have? The first part of it, where the function has to be 1 to 1 and it should contain all the values from minus 1 to 1. It is possible from this value of minus pi by 2 to this value of pi by 2, right? The next one is what? We need to understand that it also should be onto. Here, it has to be surjective function, both injective and surjective. When we talk about the onto part is what? For every value, whatever we have of y, there should have been, or there should be a value of x in general, correct? So, if you have any value of y between minus 1 to 1, then we do have a value from pi by 2 to minus pi by 2, correct? Take any value. Take any number from 1 to minus 1 or minus 1 to 1. We have a value for x, which is between minus pi by 2 to pi by 2. So, the function is also onto, and the proof of that is in the graph. See, it is a continuous graph from minus pi by 2 to plus pi by 2. See, it's a continuous graph. Since it's a continuous graph, all the values of y are covered, or in other words, we can say there is a pre-image for every value of y. It is onto also. That means what we have is that between minus pi by 2 to pi by 2, the sine inverse function is both 1 to 1 and onto, correct? So this is what I was trying to tell you in the last one. Of course, with the graph, it is a lot more easier, correct? Now, the graph of sine inverse of x is not going to go like this, correct? Not like a sine function, because the range and domain are different. So when you have that, the graph is going to be a little bit different. Fair enough? So what you're seeing here, see, this is the sine inverse function graph. Okay, sine inverse function. Same way, cos inverse, tan inverse, cosecant inverse, secant inverse, cot inverse. See all the graphs. Now what you're seeing here, see all the graph, all 6 inverse trigonometric function graphs are here, correct? So now what we got is that we understood how and why the domain and range value is going to be in that particular way. Then we also understood the graphs of inverse trigonometric function, correct? In the next video, you're going to understand the next topic.